Assalamualaikum. So today we are going to look at the new subtopic that is optimum cross sections for open channel. So optimum cross section for open channel, that is the geometrical shape of the channel, will influence by the value of the cross sectional area, weighted perimeter, and hydraulic mean depth. So from example 3.2 and 3.3, it is shown that the velocity and flow rate in open channel depend directly on the value of hydraulic mean depth. What does it mean by this? When the Q depends on the geometrical shape of the channel, okay, definitely Q equal to A times V. So A is the area, geometrical shape of the channel. Therefore, the optimum cross section can be determined by the geometrical shape which produce the maximum flow rate for a given channel roughness and slope, that is S, and also the cross-sectional area. So in case of the maximum flow rate, Q maximum occurs so that the flow cross-sectional area will be at its maximum. Okay, so when Q maximum, while the weighted perimeter is at its minimum. Okay, what do you mean by this? So let's look into this equation. Q equal to AV. Okay, so velocity here, okay, is we determine by using the GZ equation, right? So we have equation C here, coefficient C, so meaning GZ equation. So V equal to C square root of MI. Okay, so velocity is determined by the hydraulic mean depth and slope. So we focus on this hydraulic mean depth. M equal to A over P. So when M is high, okay, so it is directly proportional with area. Okay, when area is high, so it will give the hydraulic mean depth increase, okay, while the weighted perimeter is decreased. So weighted perimeter here is inverse proportional with the hydraulic mean depth. So to get the higher M, the weighted perimeter must be lower, small value, smaller than the area. Okay, so that will give the higher higher hydraulic mean depth M. So when we have higher M value here, so when we put into this GZ equation for velocity, so automatically we will have the higher velocity. So higher velocity will cause the maximum flow rate, higher flow rate. So this is what does it mean by Q maximum will occur when the area is maximum while the weighted perimeter is in minimum. Okay, so let's look at this figure. Example 3.4. So we need to determine the optimum cross section. Optimum. Given that flow in the channel shown in figure 3.7, okay, is a maximum, this question said that Q maximum. Okay, and we need to identify the dimension of the channel, because from this figure kita tak tahu the value of D, the value of B, and also the side, this side. Okay, so how we can identify this? First, this is the solution by using the cheesy equation for velocity. So we put Q equal to AV, so V is C mi K square root. So we rearrange of this formula, we get AC times A over P. Okay, so kita kembangkan yang M tu kan, M is equal to A over P. Okay, so now A is, so how we need to identify A? Okay, so kita tak tahu dia punya B and depth of the flow. Okay, so from the figure, okay, we know that this is okay. So we have here B, okay, and then we have the ratio of 1 to n. Itu saja yang dibagikan dalam figure. So this is your D. Itu pun tak tahu juga. So macam mana nak identify the A area? Sebab kita tak tahu B, kita tak tahu D kan. So kita buat macam ni. So when 1, okay, ratio 1 ni 1 ratio to n, so D is what? So ni kat sini kita tahu bila D ni project kat sini lah kan, D, so ni D. Okay, 1 is ratio to 1 is D and n is what? X kat situ kan. Okay, so kita letak when 1 is ratio to n, so D is ratio to what? X. Okay, so X is what? X is, kita darabkan dia D times N, so X is ND. Okay, so X here, ND here, we put inside this, tergantikan dia ND, and then we have okay, we have this side is hypotenuse kan, hypotenuse. So when how we need to identify the Y? So formula hypotenuse, Y equal to, okay, X is this one right, ND, ND, okay, square plus D, this one D square, square root. So you get your Y, apa ni, hypotenuse kan. Ingat tak rules of the sin cos theta? So this one adjacent, opposite adjacent and the hypotenuse cos theta itu kan. Okay, so we have your Y here, and D square plus D square. So kita pun keluarkan D tu, simplified dia. So you get n square plus 1. So since 1 square is still 1 lah. Okay, so kita letaklah juga sebab dia letak dalam tu kan. So this is your Y. So masukkan dalam formula P, weighted parameter kan. Nak kira weighted parameter is what? P B ini B plus this is Y and this is Y. So that's mean P plus 2Y. So since Y is, this one is, so you masukkanlah dalam formula parameter Okay, so you get your P in the B and N and D punya sebutan. Okay, so settle for P. How you need to determine the area? So area is for trapezoidal. So formula trapezoidal is okay, so kita akan dapatkan 2 section actually kan. Section for the triangle and rectangular. So kita tahu B times D dapatlah section rectangle ni. Okay, so N. Okay, so kita ada yang ni N times D because this is ni tadi X kan, X this N times D. So N times D times D half, so divide by 2. Since we have 2 triangle section, so times with 2, so 2 mati, so you get N D square. So we simplify, we get B plus N D times with D. Okay, that is equation for area. Okay, kita rearrange lagi, dapatkan in the B and in the form of P. Okay, so kita for the given values of cross section area and the side slope, the weighted parameter must be at minimum if the flow rate is maximum. So kita substitutekan equation 3 into equation 4. Okay, so masukkan, so kita simplifykan for the maximum flow rate. So this is the formula for maximum flow rate. So the rest is just derivation, macam mana kita nak identify dia punya perimeter pula. Okay, and then this is the derivation how we need to identify the theta. Okay, the angle of the angle of the slanting section tu. Okay, when the weighted parameter should also be at minimum with respect to the side slope N. For maximum flow rate, kita kena differentiatekan dia punya weighted parameter dengan dia punya slope. Okay, N. So this is from formula weighted parameter tadi. Okay, so kita dapat, kita solvekan equation yang ni, and then you get this one. So dapat N equal to 1 over square root of 3. So since tangent theta, so macam mana kita tahu tangent theta tu? Because this is 1 to N. Okay, so tangent theta is, tangent is opposite over adjacent. Okay, so opposite over adjacent, and sorry, theta here. Okay, okay, theta here. So kita nak tahu yang theta sini kan. Okay, so theta is tangent 1 over N to the equal to square root 3. So kita solvekan formula, so you get theta is 60. Okay, this is your theta 6